Welcome to this benchmark video. We're recording here at our conference in Washington, D.C. For this video, I'm joined by Turner Caldwell, the CEO and founder of Mariana Minerals. Turner, how are you doing?
Doing well. Thanks for having me.
Enjoying the conference?
Yeah, no, it's great.
Hey, thanks for being here. We'll know, I think the main aim of this video is to learn more about Mariana Minerals, your business. I would like to start with you. Can you tell a bit more about yourself, about your professional background, and basically your journey towards founding Mariana Minerals?
Yeah, absolutely. So I'm from San Francisco originally. Went to Stanford, mechanical engineering background. That's how I know the two other co-founders that started Mariana with. Then spent about a decade at Tesla, wore a bunch of different hats, started out up in Reno, Nevada, was working on the design and construction of the Gigafactory up there, which is our first greenfield kind of factory that we built. Mostly focused on Panasonic's side of the facility, so designing all the facility systems and a lot of focus on how do you integrate the manufacturing processes and the factory design into like one product. Then spent a good amount of time doing 2 weeks in Japan, 2 weeks in the US, working very closely with Panasonic on battery cell manufacturing and incremental improvements to their legacy battery cell manufacturing processes. Got a bunch of projects over the line, which was super exciting, fun kind of back and forth between the Tesla kind of mentality and approach and the Panasonic approach. And then spent a good amount of time kind of mapping out the cell component supply chain. So a lot of time in China and Korea and Japan, building out early techno-economic models for the cathode materials, anode materials, separator, electrolyte, the foils. And it was a part of the value chain that we, back in 2017, 2018, didn't have an immense amount of visibility into, but we knew was going to be a bottleneck in the medium term and in the long term. Then worked at the intersection of cell chemistry decision making and cell form factor optimization. We obviously had been using high nickel cathodes, high nickel cells, cylindrical form factor 2170 from 18650 to 2170. Spent a good amount of time on the introduction of LFP into our product portfolio as we were launching in China. So a lot of time with the cell producers in China, CATL, BYD, and a lot of the tier 2s.
You must have learned a lot from them then.
I would say it went both ways.
Okay.
But definitely was interesting to see the pace at which LFP was getting closer and closer at the product level to be able to kind of fit in standard range vehicles, and then it became pretty clear that stationary storage was going to eventually be dominated by LFP. So a good amount of time with the cell manufacturers, and then also kind of running around the company figuring out what had to happen on the module design, the pack design, the battery management system, the power electronics to accommodate a different electrochemical system coming into the vehicle platform. Worked on some acquisitions in the cell manufacturing space, and then once Tesla decided to make cells as part of kind of augmenting the supply base, started building teams within the company to vertically integrate into the battery value chain that I had spent a ton of time mapping out. So was very early in building our cathode manufacturing team and built out our lab, built out our pilot, led all of our process and material development at pilot scale, and then staffed up the team to build our commercial scale cathode plant in Austin. And then as that was getting handed off to the operations team, carved out a group and more formally started our minerals and metals team at Tesla. So
vertical integration, that's what Tesla is known for.
Definitely a big part of the mission and the ambition. So started our lithium refining efforts and took that from flow sheet selection, lab scale de-risking, pilot scale de-risking, vendor selection, project execution, engineering, project execution, and staffing up the operations team. Took over our battery recycling efforts at the company and kind of got that ramping to process our internally generated scrap as well as products that were coming back from the field. And then as part of that, grew the team out to a few hundred people working across some project development focus, but a lot of focus on refining flow sheet optimization for lithium, nickel, cobalt, manganese, iron, graphite, copper, aluminum, everything that gets mined and ends up in a cell. So was a ton of fun, great 9 years and change of sprinting, and then left in the middle of 2024 and started Mariana in August of 2024.
So nearly 10 years, and I assume you worked together with Elon.
Good amount of interface,
Yeah, how was it? I mean...
I think the thing that...
you didn't burn out, so that's
I think the thing that's really impressive about the leadership at Tesla is there's this methodology of asking like the 5 whys. I would say at Tesla it's more like the 10 whys, which is a good forcing function to push the teams down into the first principles of like not taking for granted assumptions that can cascade into higher cost or can cascade into suboptimal designs. And that's a methodology that really everyone should employ in terms of pushing the teams to think really deliberately from a first principles perspective. So that's definitely something that
I read the book of Walter Isaacson, so it's a fascinating journey. Thanks for that. It's fascinating. Over to Mariana Minerals. It's called a vertically integrated software minerals company. Can you add a little bit of flavor about this?
That's right. So the motivation for this kind of came from spending a lot of time with the mining companies and the refining companies, as well as kind of building a refining organization within Tesla. And one thing that became very apparent is that we have this massive labor pool deficit where the bulk of new metal capacity that's come online in the last 25 years, it's probably a little bit longer, really has come from very aggressive growth, both domestically in China and internationally from Chinese companies. And the Western minerals industry has kind of like stopped growing aggressively. There is still capital that's being deployed, but it's mostly to offset grades dropping and deposits getting deeper at existing assets. And when you stop building really aggressively, what happens is you start to lose the muscle memory of how do I very cost effectively design and construct and commission an asset, both cost and schedule effectively, but also optimize those assets on an ongoing basis. And so another big piece is that when you stop being a growth industry, the labor pool starts to stops participating, right? Like the minerals industry is kind of at the bottom of the list of folks that are graduating from college and of industries that they want to go into.
I think, if I may interrupt, I think rare earths is a good example, because in the 60s, 70s, the US dominated that industry. Now it's dominated by
too.
China.
And some of the early lithium projects were built in the US. If you go back 50 years, the US was a much larger percentage of metal supply. And that's kind of just stopped happening. And some of it's regulatory, some of it's capital participation, but those things ultimately lead to labor pool participation. And we don't really have the time with this broader reindustrialization effort, as well as these demand drivers from AI infrastructure, robotics, defense, kind of becoming a major focus. And 5 years ago, it was mostly the energy transition story that was driving demand on the metal side. Now it's way more plus the energy transition story, or the renewable energy penetration story. So we have this big problem. We can't wait 25 years to retrain a labor pool to figure out, to relearn how to do this stuff. And so our entire thesis is that you have to build better software to augment the existing labor pool and make a series of big bets on autonomy, both in engineering, procurement, and construction, using the advent of large language models to build agents that can accelerate engineering activities and automate a lot of engineering tasks.
It's really the operational side of the...
Well, that's on the construction side. That's the EPC side of things. Okay. And focused on how do you iterate faster on designs, how do you make procurement decisions faster, how do you operate construction projects like a manufacturing facility. And a lot of EPC construction is ultimately a big coordination exercise, right? It's the coordination layer is the messy layer because you have dozens of engineering subcontractors, you have a large complex equipment supply chain, and you have dozens of construction subcontractors, and they're all working out of data silos, and we kind of lack a single source of truth. And so part of the business is how do we become the best EPC and drive down cost, because the minerals industry is very sensitive to CapEx and project execution time, right? Those are the things that kind of kill projects. And then on the operating side, AI is this broad, buzzy term, but if you break it down into the tools that actually build up to AI, for refineries, we build world models of the chemical plants internally, going down into the first principles, and then augmenting those world models with data from lab and pilot scale infrastructure. And then we use reinforcement learning to remove humans from the loop, remove metallurgists from the loop, and process engineers from the loop in determining all of the set points for a refinery. And that's important because typically the flow for making changes to how a refinery operates is you'll manually sample various parts of the circuit. That runs to the lab. The lab analyzes the samples. That data comes out to the process engineers. The process engineers look at the data. They'll submit a process change request. It gets reviewed, and then you make a change to the set points. And that can take days. And so you're really pretty far away from doing short interval control on these refining assets. And that two inefficiencies come out of that. One is your feedstock is constantly changing, right? Like the earth is heterogeneous, and so what is coming out of the ground has a different mineralogy, it has a different grade, it has a different impurity profile. And really the entire industry focuses on like, how do I stabilize the composition of the feedstock into the refinery through blending and kind of actually pushing some inefficiencies upstream. And so what short interval autonomous control unlocks is on 15-minute intervals, the reinforcement learning agents are actually changing directly in the process control system with no human in the loop, so that you can adapt that variability in the feedstock. And so you're basically saying we should mine as efficiently as possible because we can figure out how to process as efficiently as possible. Then on the other big bottleneck that the industry faces that we're addressing is the ramp-up period for these refineries.
Okay.
And I'll use the China example where when Chinese companies build new refining circuits overseas, they have this very deep, very mobile, and very experienced workforce that they're able to like move from site to site regardless of the geography. And that means that the ratio of people that understand the chemistry and understand how the refinery is supposed to operate to the like local labor pool that is being trained is closer to like 1-to-1, might even be higher than that. Okay. Versus when Western minerals companies build plants, the ratio of expats to kind of onshore labor is much, much lower. So that means that the ratio of people that know how to commission a plant you're like deficient on that labor pool. And that brings us back to the labor pool problem of being able to tune the circuit while you're in that ramp up period, trying to achieve nominal output and make a quality product on the back end. And so that's what PlantOS does. That's our internal kind of refinery management system. And then MineOS is our internal mine management system. Okay. We do something very similar. We build world models of the mines. We then pair that with autonomous assets, autonomous excavators, autonomous haul trucks, autonomous drill rigs, autonomous loaders and dozers, and water trucks. And the telemetry off of all those assets and the autonomous execution is married with the world model, which is used to train reinforcement learning policies that then orchestrate the autonomous assets. So what you're trying to do there is kind of remove humans from the loop in determining how does a mine operate on a minute-by-minute basis. Okay. And that's obviously aimed at this shortage of mine operators that we have, but also this shortage of mine planners that we have. Yeah. Because on a large, complex mine, you're making more than a decision a minute, obviously. Like you're making hundreds of decisions every minute across the mine. And that's challenging for humans to keep up with and maintain high efficiency on a minute-by-minute basis. So autonomous short interval control for mining, autonomous short interval control for refining, and then a software stack for accelerating capital project execution. And so we build all that internally. We have around 250 people now, and about 20% of the company is software engineers, machine learning engineers. Okay. But the rest of the company are the subject matter experts, the folks that know how to develop robust chemistries, the folks that know how to design resilient infrastructure, build that infrastructure, commission that infrastructure, and operate that infrastructure. Okay. Where the moat kind of comes in, or where the advantage comes in for the company, is having a very integrated team between folks who are developing the software and folks who are ultimately using the software. That enables you to build the software faster, it enables you to iterate on the software faster, and enables you to deliver product to market faster. And we don't sell SaaS, so we're not a SaaS company. Okay. We layer that software stack on top of assets that we build and that we operate. Okay. And so we have a copper mine in Utah, Southeast Utah, that had been operating for about 15 years. We took over at the end of last year, copper mine and refinery, so open pit, bio heap leach, solvent extraction, electrowinning. And we took over that asset. We restarted mining operations a month and a half ago that were paused at the end of 2024 with kind of 50% autonomous operations and 50% manned, with the goal at the end of the year, maybe bleeding into Q1, of no human in the pit operation. So that's our copper asset in Utah. In parallel, we're building a lithium extraction facility from oil and gas wastewater. Really more of a speed to market play. There's also a large lithium resource that's contained in water that's currently flowing at the surface today. So water is co-produced with fracking, like oil and gas from shale formations. And that water contains lithium, a bit more dilute than some of the brines in South America. But because you have this CapEx shift of not having to drill wells, both for extraction and disposal, you can start to chase these lower volume, lower concentration feedstocks and bring them to market. So we're building a lithium extraction facility. It's a partnership with a company called Select Water that has an existing pipeline that aggregates water from about 1,000 different wells, oil and gas natural gas wells. It's all aggregated in one spot. We divert the water stream, extract the lithium, give them the water back for disposal, and then we'll sell a lithium carbonate product.
Okay, that's a whole bunch. Wow.
Yeah, sorry, I threw a lot.
Yeah, no worries. But translating your goals you outlined, I mean, in a nutshell, making the mining and the refining space in the US more competitive, more streamlined, more efficient, with the help of your
I mean, the goal ultimately is to like flatten the cost curve with autonomy. And as we're starting the business, it's about identifying projects that otherwise would have been in the third or fourth quartile of the cost curve, and shove them into the first or second quartile of the cost curve.
Okay.
But then eventually, as we start to chase scale, we'll start to go after the tier one assets and just build them faster and operate them more efficiently.
Okay. And I want to talk about copper in a moment because I want to translate what you've said to a couple of projects. You outlined your project, the copper project. But translating that into the refining space, I mean, that's arguably an even bigger bottleneck challenge. Can you tell a bit more about a project you're working on, the refining space?
Yeah, so the lithium project is just a refinery, right? So like Bryan comes in, we do a pre-treatment step, we run through a direct lithium extraction step, we do impurity precipitation, we do concentration, then we crash out a lithium carbonate, precipitation and then crystallization. And that is just a refinery. The copper asset has a co-located refinery. And as you look at the challenge...
It's copper concentrate then?
No, we're making copper cathode.
Oh, copper cathode, okay.
Yeah, 99.99.
Okay.
And so both of our sites are refineries. The copper site is vertically integrated with the mine. And as we continue to scale, there will be some projects that are just refineries, right? And it depends on the metal. Like I'd say that rare earths today is a good example of an industry that is more refining bottlenecked than mining bottlenecked. And so as we start to look at getting into the rare earths industry, we would probably focus on refining, where reinforcement learning control of the extraction circuit and the separation circuit is actually quite well suited to solve the challenge we have, which is that we don't have all the engineers that actually know how to separate all the rare earth elements from each other. And there are other metals where we're both mining and refining constrained. Uranium is a good example. Magnesium is a good example.
And you've got a partnership with the metals company, right? To look at the feasibility of a potential nodule processing facility in the US?
Yep. So we're partnering with them, focused on the processing and then refining of polymetallic nodules. Those feedstocks are complex, mainly because they have so many metals. And obviously that's good for the economics because you're making multiple products from a single feedstock. But that comes with additional complexity on effectively separating all the metals from each other. And again, that's a good example of where reinforcement learning control and removing humans from the loop and determining how these assets operate end to end is ultimately going to enable us to move much faster in building that capacity in the US.
You founded the company in 2024. Back then it was still on the, let's say the previous administration broadly, where the big framing around minerals was energy transition, electric vehicles, batteries. Now it's shifted a lot more to energy security, where batteries arguably still play a big role. But now it's a lot more about AI, data centers, defense. How has this impacted your business and your pitch and your business case more in general?
Yeah, I think the thing that's exciting about critical minerals is that they are bipartisan and they should remain bipartisan. They are critical, like depending on the framing, it's all the same metals. And the reality, whether regardless of like which administration or which party is kind of like driving things forward, we're going to need critical minerals. And there's like no real way around it. And this like soft spot that we have in our supply chains, or this weak point that we have in our supply chains, is one that we have to fix. I'd say in terms of like how it's impacted the business, it's definitely always helpful to have tailwinds, which we definitely have right now with the current administration. And they've been doing a ton. Like we're seeing like permitting move faster at the like field office level. It's important for Congress to basically like lock that into law through permitting reform, so that it's not shifting back and forth as things move around. But we're definitely seeing the impact of the increased focus in the U.S. right now.
Yeah, and I think a last question I want to go into is copper. We talked about the demand drivers, AI, data centers, pretty bullish for copper. But why? Just Yeah, can you tell a bit more? Why did you enter in the copper space?
Yeah, so we when you're building a company from like the private side of things, it's like really important to focus on big markets where you can where you have a lot of room to run. And copper is, it's Dr. Copper. It's been like the heart of kind of like, it's been from the metals perspective, it's like steel and copper are like the two, or iron ore and copper are kind of like the two that are going to have staying power for a very long time. Aluminum is also on that list. But the copper has this like very interesting dilemma that it's facing, where a lot of people talk about ore grades dropping, a lot of people talk about deposits getting deeper, but the example that always gets cited is copper. Like copper is getting harder to extract, it's getting harder to refine, and the labor pool is going in the opposite direction that it needs to go in. And add on the tailwinds of the demand side, where copper's not going anywhere unless prices go to like $20,000 a ton, at which point you'll probably start to see some substitution risk and probably start to see some demand destruction. I mean, we're already starting to see some of that at current prices. But it is hard to substitute away, just because like all the downstream infrastructure is like designed to take copper. So the reason we jumped in is because we saw a very clear application of like our software stack to solve the problems that the copper industry is facing, which are more complex refineries, mines that are more sensitive to mining cost, and where as you go deeper in deposits, like right now we do open pit mining, but as we start to look at underground mining operations and the copper deposits are getting deeper and deeper, getting humans away from that operation is a big win, both from a safety perspective and primarily from a safety perspective, but also from an efficiency and a cost perspective.
And perhaps a last little follow-up question. I mean, you've taken over a copper asset in the United States. You will refine copper as well into copper cathodes. But as you know, I mean, there is a lack of copper refineries in the United States. What's the outlook in the US according to you? In that regard.
We need to build more refineries. I think that so like right now, if you look at the copper balance in the US, if you were able to process 100% of the copper scrap, you would actually fill all of your copper demand domestically, and that demand's going to go up, and it's going to, like, that supply-demand balance is going to look different if we don't continue to scale production. But what we're doing right now is we're actually integrating copper scrap recycling into the existing refinery that we control. And so you can use the existing solvent extraction and electrowinning infrastructure to take insulated copper wire, copper chops, and potentially even more kind of like higher impurity feedstocks into existing refining infrastructure, and that's what we're deploying right now. We have our kind of like small commercial line that is getting commissioned today. We'll be ramping that because we have 25,000 tons of capacity right now. We'll fill out the refinery with scrap, and then as we expand mining production, we'll ramp the refinery to 50,000 tons. So, it's not a Kennecott scale operation or a Morenci scale operation, but it's a good place to start for a company that's 20 months old.
Thanks. Yeah, it's a fascinating company. Thank you so much for the discussion.
Yeah, no, absolutely. Thanks.